Hello everyone, a warm welcome to my channel. Today the topic of discussion is how to solve numericals on modular exponentiation. In the previous video, I have taught how to solve modulus of positive integer like a mod b and a negative integer that is of the kind minus a mod b. So if you want to know how to solve these numericals, kindly go through my previous video whose link is given in the description section. Today we are going to learn modular exponentiation. So in this video we are basically going to learn how to solve a raised to power x mod b. Now you will say, okay, I will put it in the calculator and compute the answer. Now let us say you come across a computation where you require to compute this particular value. Now the number gets bigger. When you try to solve 34 raised to 569, you try to do it on a calculator, the number gets much bigger and the mathematics gets much more complex. So it is very tedious for computing devices to perform computation of such large numbers. The algorithm takes huge amount of time to solve such modular exponentiation. So today we are basically going to look into a very quick and easy way of solving the modulus of exponentiation and particularly of very large numbers. So coming to the question, what is modular exponentiation? It is basically a modular arithmetic which is done over exponentiation. How is it represented? As I told you, we represent it at a raised to x mod b. What is the answer? We'll get an answer which will typically be a positive number and it will be between 0 to b minus 1. Now, if it is a small numerical like 2 raised to power of 8 mod 7, you can just solve it in the similar way that we had solved in the previous video. So 2 raised to power of 8 is 256 mod 7, and the answer to this is, if you divide this 256 by 7, 7 into 36 gives us 252 and the remainder is 4. Therefore, the answer to the given question 2 mod 7 is equal to 4. However, here we are dealing with a smaller number. But if you get a very large number, such as let me say 2 raised to power of 1000, it will come out to be a very large number, and for the mathematics of solving this becomes complex, and hence we have to find an easier way around, which I'm going to teach you today. So let us directly jump into solving the questions now. Before that, we'll see some basics about exponentiation, which we are going to require when we solve the question. So let us say, what are the different ways you can represent the number 6 raised to power of 8? 6 raised to power of 8 is nothing but 1679616. Now before going to how can we represent it in different way, I would like to discuss, suppose I want to reduce this number into a small number, okay, and typically I want to bring it between say 0 to 19. What will you do? You will take 6 raised to power 8, which comes out to be a large number. So you will apply a modular arithmetic to this, and because my last digit is 19, I want my answer to be from 0 to 19. I should use 20 here because the answer that we get, I want it between 0 to 19, that is 0 to b minus 1. So b minus 1 is 19. So b is equal to 20, and we typically write this as a raised to x mod b. Okay, so if I want to reduce any large number into a number within a finite field of numbers, and in this case the finite field is between 0 to 19, we do modular arithmetic. Now coming to this question back, how can I represent 6 raised to power of 8? 6 raised to power of 8 can be represented in this different ways. For example, I would have just written as 6 into 6 into 6 8 times. So this is one way of writing. Second way of writing would be, I would club these two together and I would have written 6 raised to 8 is 6 square into 6 square into 6 square into 6 square. Or I would have written it by clubbing these two together as 6 raised to 8 is equal to 6 raised to 4 6 raised to 4. How would you write 6 raised to power of 7? It would be written as, so there are different ways of writing. One way is 6 raised to 4 into 6 raised to 2 into 6 raised to 1. That is basically 6 raised to 4 plus 2 plus 1 comes out to be 6 raised to 7. With this basic knowledge, we'll go ahead with solving few questions on modular exponentiation. So let us take certain examples. First is we'll take modulus of a positive number. We'll just quickly revise what we did in our previous video and which we are going to require today, and then we'll go ahead with solving the question. Now I want to find what is 150 mod 7. As I discussed in the previous video, whenever you want A mod B, the answer is C, which is obtained by dividing A by B, and the answer is always positive and it is between 0 to B minus 1. So to solve this, you have to divide 150 with 7. So 7 into 2 is 14. We get 10. 7 into 1 is 7. My remainder is 3. So you have to check, is this number positive? Yes. Is this number between 0 to B minus 1? Now B in our case is 7. So B minus 1 is 6. So is this number between 0 to 6? Yes. Therefore, this is my final answer. And hence you write 150 mod 7 is equal to 3. Now let us go ahead with solving the exponentiation part. Till now, I got 150 mod 7. Now suppose I am asked find out 150 square mod 7. So I am not going to solve 150 square on the calculator. Well, I'll solve it in the other way. Why I'm not putting it in the calculator? Because if raised to the power is very large, then your calculator may not even give you the answers because it is very large. So we have to find an alternative way of solving this, and the method is as I'm going to show you now. 150 square mod 7 can be written as 150 into 150 mod 7, which becomes, now I know the answer of 150 mod 7, which is 3. So this answer I got 3 and this answer I have put 3. So 3 into 3, 9. Now if the answer is 9, you have to ask two questions. Is it a positive number? Yes. Is it a number between 0 to B minus 1? How much is B? B is 7. So B minus 1, that is 6. So my answer to this question is no. It is not between 0 to 6. I should again perform modulus over this. So 9 mod 7, because the answer is always between 0 to B minus 1. Now how do you do 9 mod 7? Take number 9 divided by 7. So 7 into 1 is 7 and my remainder is 2. Therefore, my answer of 150 square mod 7 comes out to be 2. Let us see a higher exponentiation now. So till now, I got the answer 150 raised to square mod 7 is 2. Now let us say we are asked to solve 150 raised to the power of 4 mod 7. So how do I do it? So as I discussed, how can you represent this exponentiation? I can do it like 150 square into 150 square mod 7. Now separating out the bracket. Now since I know the answer of 150 square mod 7, which is 2, I will write 2 for this and then 2 for this. 2 multiplied by 2, I get the answer 4. The moment you get this answer, you have to ask two questions. One, is it positive? Yes. Second, is it a number between 0 to B minus 1? Now, what is B in our case? 7. What is B minus 1? That is 7 minus 6, that is 6. So yes, even this is satisfied. So my final answer for this question is 4. So with these answers that I computed, let me say now I want to find what is 150 raised to mod 7. So 150 raised to the power of 7 can be represented as 150 raised to the power of 4, if I have calculated 4 already, multiplied by 150 raised to the power of 2, which I've calculated and I know the answer. So what is left out now is 150. So it basically becomes mod 7. So this basically is nothing but 150 raised to 4 plus 2 plus 1. So 150 raised to 7. So you have to split up this 7 into subparts and then perform the calculation. So now I'll split up the bracket. So 150 raised to 4 mod 7 into 150 raised to the power of 2 mod 7 into 150 raised to the power of 1 mod 7. Further, you write down the answer for each part now. So 150 raised to the power of 4 mod 7 is 4 into 150 square mod 7 we got 2 into 150 mod 7 we got it as 3. So if I multiply all these three numbers on the calculator, I will get the answer is 24. Now when you get this, there are two questions you are supposed to ask. Is it positive? Yes. Is it between 0 to 6? No. So therefore you have to again perform 24 mod 7. Now how do we perform 24 mod 7? Every one of you know very well. You have to take 24, divide it by 7. As you know, 7 into 3 comes out to be 21 and the remainder you get is 3. So is this positive? Yes. Is it a number between 0 to 6? Yes. So my answer to 150 raised to the power of 7 mod 7 is 3. So this is the answer I got to this particular question. A quick revision on what we did. We were asked to find out 150 raised to the power mod of 7. We first started with finding what is 150 mod 7. Then we squared it and then found 150 raised to square mod 7. We again squared it and found 150 raised to 4 mod 7. And we can easily solve these squared parts because we have a knowledge of the previous computations. And then we can come back to the main question, substitute all that you have computed and find the answer. Let us try to solve this particular question where I am asked 13 raised to 15 mod 7. So instead I have to find 13 mod 7. I already taught you how to find 13 mod 7. You take the number 13. So when you divide 7 into 1 is 7 and your remainder comes out to be 6. Now you have to check, is the remainder positive? Yes. And is the remainder between 0 to 6? Yes. So this is my final answer. So I write it down here. The next step is to find out 13 raised to the power of 2 mod 7. So how do you do that? So 13 raised to the power of 2 mod 7 can be written as 13 into 13 mod 7. If you separate out the brackets, it becomes 13 mod 7 into 13 mod 7. Now since you know what is 13 mod 7, 6 into 6, I get 36. Now you have to ask two questions. One is it a positive number? Yes. The second question is, are you getting the answer between 0 to b minus 1? B minus 1 is 6. So I'm not getting an answer between 0 to 6. Therefore, I should perform mod operation on this. Now how do you perform mod operation on this? 36 divided by 7. 7 into 5 is 35 and I get a remainder which is 1. Now again ask the question, is the remainder positive? Yes. Is the remainder between 0 to 6? Yes. Therefore my answer to 13 raised to the power of 2 mod 7 becomes 1. We now go to the third step of finding out 13 raised to 4 mod 7. I will write this as 13 raised to the power of 2 into 13 raised to the power of 2 mod 7. Separating out the brackets, it becomes 13 raised to the power of 2 mod 7 into 13 raised to the power of 2 mod 7. We just computed what is 13 raised to power of 2 mod 7. So you put it down. This is first bracket. If you put the answer, it is 1. Second bracket, answer is 1. Then 1 into 1 is 1. Now ask the question, is it positive? Yes. Is it between 0 to 6? Yes. So 1 is my final answer. Coming to the next step of 13 raised to power of 8 mod 7. You can do it by doing 13 raised to 4 into 13 raised to 4 mod 7. So this becomes 13 raised to 4 mod 7 into 13 raised to 4 mod 7. So 13 raised to 4 mod 7 is 1. Another 13 raised to 4 mod 7 is also 1. So the answer of this is 1. After having computed step 1, 2, 3 and 4, we reach to the question 13 raised to 15 mod 7. So 13 raised to 15 can be represented as 13 raised to 8 into 13 raised to, I've got 4, so I can put 4. Then I can put square because I've computed square. So 8 plus 4 is 12. 12 plus 2 is 14. And 1, if you add 1, you get 15. So you can do this way, mod 7. That is basically 13 raised to 8 plus 4 plus 2 plus 1 gives us 13 raised to 15. So I have used these values here. Now separating out this bracket, we get 13 raised to power of 8 mod 7 into 13 raised to power of 4 mod 7 into 13 raised to power of 2 mod 7 into 13 mod 7. Substitute the answer of each. So answer of 13 raised to power of 8 mod 7 is 1. 13 raised to 4 mod 7 is again 1. 13 square mod 7 is 1 and 13 mod 7 is 6. So the answer of this is 6. When you get 6, first you have to again ask, is it number positive? Yes. Is this number between 0 to 6? Yes. So because it satisfies both the criteria, you 15 raised to 15 mod 7 is 6. Let us now to solve few more numericals. So 3 raised to 20 mod 8 25. So as you can see, I have taken a larger number for modulus. Just a quick revision. Why do I do mod 825? I do mod 825 basically to ensure that the answer of the computation that you get is between 0 to b minus 1. So in this case, b is 825. If I want my algorithm to process only numbers between 0 to 824, I'm supposed to use a modulus arithmetic. So modulus arithmetic ensures that your number is always within a finite set of numbers. So in order to bring any a large number, you want to convert it to smaller numbers, you use modular arithmetic and convert it to between the range that you expect. So let us see how to solve this question now. So my first step would be 3 mod 825. So how do we solve this? I've already taught you in the previous video. However, I'll do it again so that it becomes a practice for you. I take 3 and I divide it by 825. So 825 to 0 is 0 and my remainder is 3. Or I've also told in my previous video that whenever you're doing a mod b, where a is positive number and a is less than b, in this case the answer is directly a. So we get 3. Now coming to the second step, I will do 3 raised to power of 2 mod 825. That becomes 3 into 3 mod 825. So if you split it up, it is 3 mod 825 into 3 mod 825. Now since you know the answer of each, it is 3 into 3, which is 9. So 9, you have to ask two questions when you get the answer. Is it positive? Yes. Is it between 0 to b minus 1? Now b is 825. So b minus 1 is 824. Yes, it is pretty much between 0 to 824. So 3 square mod 825, we got the answer as 9. Then we proceed to the third step where we want to find 3 raised to 4 mod 825. I'll use a different color so that you understand the step. So here I will do 3 raised to 4 can be represented as 3 raised to 2, 3 raised to power of 2 mod 825. That is 3 square mod 825 multiplied by 3 square mod 825. Now what is the answer of 3 square mod 825 is 9, and another 3 square mod 825 is also 9, which you get as 81. When you get 81 as the answer, you ask again two questions. Is it positive? Yes. Is it between 0 to 824? Yes. Therefore, answer is equal to 81. So in step number 1, we found what is 3 mod of 825. Our answer was 3. Step number 2, we found what is 3 square mod 825. The answer that we got was 9. In step number 3, we performed 3 raised to 4 mod 825. The answer that we got was 81. In the fourth step, we compute 3 raised to 8 mod 825. So 3 raised to 8 mod 25 can be solved by doing 3 raised to 4 into 3 raised to 4 mod 825. That is 3 raised to 4 mod 825 multiplied by 3 raised to 4 mod 825. Now we know that 3 raised to 4 mod 825 is 81 into 81. The answer comes out to be 6561. Now looking at the answer, you have to again ask two questions. Is this number positive? The answer is yes. Is the number between 0 to b minus 1, that is 0 to 824? The answer is no. So we have got a number which is larger than 824. Therefore, in order to bring it between 0 to 824, we do mod 825 again. So we have to do 6561 mod 825. So remember, whenever your answer exceeds b minus 1, you should always bring it between 0 to b minus 1 by doing modulus. So let us solve this particular part. So 6561 divided by 825. If you check on calculator, 825 into 7 comes out to be 5775, and the remainder is 786. Now the 786 remainder that you get is pretty much between 0 to 824, and hence this is a final answer to the question 3 raised to 8 mod 825. That is, the answer is 786. So the next step which we want to perform now is 3 raised to 16 mod 825. I have gone till 3 raised to 16 because the question that is asked is 3 raised to 20. So I'll perform as many computations as I can using squaring method. So I use 3 raised to 16 now. So 3 raised to 16 mod 825 can be represented as 3 raised to 8 mod 825 into 3 raised to power of 8 mod 825. What is the answer of 3 raised to 8 mod 825? 786. If you multiply these two, you'll get the answer as 617796. Now this happens to be a large number, and as I told you, the answer of any computation has to be between 0 to b minus 1. That is, this number has to fall between 0 to 825. But this is very large, so you are supposed to do modular arithmetic again on this. Now let us check out how to do this modular arithmetic. So 617796 divided by 825. So I've taught you this particular method in the previous video. However, I'll solve this one question again and show it to you. So what we do is we take the calculator and I put this 617796. I divide this number by 825, and the answer that I get is 748.843. So as I mentioned in the previous video, you have to take the number which is before the decimal point. What is the number before the decimal point? It is 748. So I'll write here 748. So again, check on the calculator. What do you get if you do 825 into 748? So the answer that we get is 617100. Check what is the remainder. The remainder is 6, 9 and 6. Check out if the remainder is between 0 to 824. So yes, it is between 0 to 824. So my answer for 3 raised to 16 mod 825 comes out to be 696. So coming to the question 3 raised to 20 mod 825. This can be written as 3 raised to 16. As I've computed 3 raised to power of 16 already, to make it 20, I need to add 4. So 16 plus 4 is 20 mod 825. So basically I've represented 3 raised to power of 20 as 3 raised to 16 into 3 raised to 4, where 16 plus 4 becomes 20. Now splitting up the brackets, 3 raised to 16 mod 825 into 3 raised to 4 mod 825, and we know the answer to each of them. So the answer of first is 696. So 3 raised to 16 mod 825, 696, which you have already computed, and 3 raised to 4 is 81, which you have already computed. You get the answer as 56376. Now, the moment you get the answer, as I have been mentioning again and again, you should ask the question, is this number between 0 to 824? So the answer is no. Therefore, you are supposed to do modular arithmetic here, that is you have to do mod 825. Now how do you do mod 825 calculation here? So you take this number 56376 divided by 825. Now I'll repeat the step again, how do we perform so that you get a hold of the technique. So I've taken the calculator here and I do 56376 divided by 825. So I get 68.33. I'm supposed to use the number before the decimal point, that is 68. Therefore here I write down 68. But I don't know how much is 68 into 825. So I do the computation of 68 into 825, and the answer that I got is 56100. So I write down here 56100 and check how much is the remainder. So the remainder comes out to be 276. Now when you get the remainder, you have to check out, is it positive? Yes. Is it between 0 to b minus 1? Yes. Therefore, this is the final answer to the question 3 raised to mod 825. So we got the answer as 276. Kindly note that I've covered modular exponentiation questions in this video because it was in continuation with my previous video where I have taught you how to compute the modulus of positive integer, the modulus of negative integer. So in continuation to this, I taught you how to compute modulus of exponentiation. In the next video, I will be teaching you how to compute modulus of multiplicative inverse. However, we can solve a modular exponentiation question using Fermat's theorem and Euler's theorem also, which I will be covering in the coming videos which I'll make on number theory. As of now, I would require how to find A mod B minus A mod B and A inverse mod B when I will be discussing on the questions on scissor cipher, Vigenère cipher and affine cipher. So I have covered these. In the coming video, I'll be discussing how to solve numericals on A inverse mod B. So thank you guys for watching my video. I hope you understood the concept of how to solve numericals of modular exponentiation. If you have understood the concepts, I request you to kindly like, share, comment and subscribe to my channel so that I can make many more videos in different subjects. So thank you guys. Thank you very much for your time. Stay healthy, stay blessed.